Hi everyone, this is a lecture on mixtures. We've already talked about mixtures and know that there are two basic types, homogeneous and heterogeneous. And we've already defined what a mixture is, which is a combination of a bunch of different things put together. Or when these things are put together, they can be whatever you like. They just have to be different. That once they're put together, they still have their own chemical identity. They still have their own properties. They retain their image and their chemical properties, meaning they don't bond together. So because they don't bond, you then can separate them by what we call physical means, meaning it's going to be a little bit easier to separate out the components that made up your mixture because they weren't chemically bonded. A chemical bond is very hard to separate. A chemical bond cannot be separated by physical means. Okay, this little slide is going to focus on separations that can be done by physical means, which means, there's a lot of means in this, which means that you have a mixture. Get it? If you can separate it by physical means, you have a mixture. So here are some of them listed for you. Hand separation, evaporation, magnetic separation, distillation, filtration, chromatography, and decanting. We've talked about a few in class. Just quickly to review, hand separation is probably the easiest to figure out. You literally just stick your hands inside the container and you can pick out each substance. So this would be something like, I don't know, imagine you have a bowl full of M&Ms. You've got green ones, you've got blue ones, maybe you have peanut M&Ms, maybe you have the pastel Easter M&Ms. So you can probably separate out your plain M&Ms from your peanut M&Ms, right? By just literally putting your hand inside the dish and separating them by hand. That's what hand separation is. Sometimes our substances are very easy to separate out. Evaporation. Evaporation is a very simple, easy technique. Let's say you have a beaker full of water and you add some salt. You just made yourself a mixture, right? That mixes very well, so it's a homogeneous mixture. It looks uniform throughout, right? The salt doesn't just float at the top or settle at the bottom. It actually dissolves throughout the entire thing. And so if you want to separate out the two components again and get the salt separated from the water, you can do that by evaporation. So you can take that beaker, put it under a Bunsen burner, maybe even putting it in an evaporating dish, which would make more sense, and evaporate off the water, and what's left behind is the salt. And so if you really want to catch that evaporated water, you might want to have some sort of a shield or a barrier or some sort of container on top that can actually trap the steam and catch it as well. So that could be a way you can get that water back too. Magnetic separation hopefully sounds kind of obvious as well. So if you have a mixture that has a component in it that is magnetic, like iron filings, what you can do is you can just run a magnet and separate out maybe, let's say, your iron filings from sand. That could be a good example. But clearly if you don't have anything magnetic in your sample, then magnetic separation would not be the technique you should choose from these listed techniques. So that leads me kind of to another thing, and not to get off on a tangent, but not all of these are appropriate. It depends which, substance or what kind of mixture you have. So you have to look and see what would be, what would make sense to do. So to continue on, next on the list is distillation. This one's probably a little new for you. Distillation is seen in the pictures down below labeled A and B. So they're the two on the left, A and B. And if you look at this apparatus, you've got a ring stand and a ring. There's actually two rings. Maybe the top one's more like a clamp. A Bunsen burner underneath, and you got a round bottom flask and a stopper up on top. And then you've got this tubing connected into an Erlenmeyer flask. So it's quite an elaborate setup. This does take a little bit of time to set up. We will not be doing this in lab, but if you've noticed, I've said distillation video. It might be good to Google a distillation video to see if you kind of don't understand what's happening by the picture seen below, if you'd like. So what happens is in your round bottom flask, you've got a solution, and if you notice there's an arrow pointing and it says salt water. So you got salt and water, you want to separate out the salt and the water. So like we said, evaporation is a good technique, but here's a little bit of a more detailed, a little bit more of an elaborate technique called filtration. Notice there's a lot more equipment here. This one will cost a little bit more too. So what you do is you evaporate the liquid, and as the water evaporates, only water evaporates. Salt does not evaporate. Solids don't evaporate necessarily. It depends on the solid. So the salt's not going to evaporate. The liquid will, and it turns into steam. See the arrow where it says steam? Then what happens is that steam, because it's a gas, expands and eventually starts to go down the tubing. Now that tubing, if you notice, it's double layered. And that tubing has an outer tubing that has cool water circulating around it. Try to make sure that you look at the labels of the picture so you see what I'm talking about. So as the steam goes down the main pipe, surrounding that pipe is really cold water. So when the steam goes down the pipe, or the tubing, it automatically hits a temperature that's very cold. And when steam gets cold, it condenses. And when steam condenses, it turns back into water. So as you notice, water starts to drip into the Erlenmeyer flask. And it says pure water. And so in picture B, you could see what happens, and that is eventually you can get all the water separated from the salt, and the salt is sitting in the bottom of the Erlenmeyer flask, or the brown bottom flask. So the important thing to know is when you are going to use distillation, it's really important to know the boiling point of a substance. And sometimes you even put a thermometer inside this whole apparatus to see, so you know which liquid is being evaporated. Because you can evaporate two liquids from each other, let's say alcohol and water, if you know their boiling points. So the last picture over here to the right is filtration, which is our next one. And if you notice, this one also you could technically Google and look at a video. This one's not as difficult. If you look here on the right, it's just a ring stand, a funnel sitting in a clamp, or even a ring can hold your funnel, a beaker, and you got a stirring rod. Inside your funnel, if you notice, there's filter paper. Filter paper is a paper that allows some liquids to go through, but it won't let solids go through. So let's say you have this mixture here of solid and liquid. You pour it into the filter paper, and if you notice, they are suspending a stirring rod. You don't want to jam that stirring rod in there. You don't want your stirring rod ever to touch your filter paper. It'll rip it open. They're basically just holding the stirring rod. They're like suspending it, and they're slowly pouring the solution down the stirring rod because you don't want to over pour so that the solution spills over the filter paper. And then if you notice, the filter paper, because of the way it's made, can hold the solid but allow the water or the liquid to go through. And if you notice that in the beaker, you just have the purple liquid and all that blue solid has not come through, so you're separating things. The liquid that comes through into the beaker that's colored purple in this picture is called the filtrate. The stuff that's left on the paper, the filter paper, is just the solid. And so the way to obtain that substance is you just let it sit out and dry. And when the filter paper dries, that solid is there and ready for you to use. So you've separated the solid from the liquid. The next technique is called chromatography. The next one is chromatography, but chromatography, can't even pronounce it, involves a little bit more detail. Again, it's a way to separate a mixture. There's a little bit more to chromatography, so actually it'd be easier if I showed you a video. So a video will be coming soon about chromatography. Just know again it is a way to separate a mixture out, and a video will be coming soon. The last one is decanting. Decanting is so easy. We do this a couple times in our lab, so this is important to remember, obviously, along with all the other ones. But decanting is, let's say, you have, let's say you have a graduated cylinder filled with water and, I don't know, let's say pebbles in it. And that graduated cylinder, you want to just have the pebbles, not the water. So what would you do? That could be really easy. Well, just take the graduated cylinder, go over to the sink, and start pouring gently the water into the sink until you empty all of it out and you're left with the pebbles. This technique obviously is used for, a mixture that's maybe more heterogeneous because it just has two distinct parts that haven't mixed. So it's extremely easy to see where they are in your graduated cylinder or whatever container you have it in, and you could separate them out. It's kind of like oil and water. You could separate the oil and pour that out and eventually reach the line where the water is. I mean, is it the cleanest technique? No, I mean, you always have a little bit of something left in your graduated cylinder, but it's a very easy way to get rid of one of the components in your mixture, as long as it hasn't mixed really well. And well, that is the end of our mixture lesson. Again, chromatography will be coming back soon. Hope you enjoyed it. These are some of the techniques we'll be doing in lab.